Hello, everyone. Thank you for joining the webinar. My name is John Stancarone, and I'm an engineer and product specialist with T Equipment. We have a really great webinar for you today. John Gold, Director of Global Business Development, Condition Monitoring with FLIR, will be presenting the FLIR Si124 Industrial Acoustic Imaging Camera and NFPA standards. At FLIR, John works directly with customers on solving their unique pains in the area of condition monitoring. With 20 years plus of experience in direct management and operational experience in the facility space, John provides a unique understanding of how customers in asset-intensive industries are best served through proper maintenance and safety efforts. So before turning the presentation over to John, while we're waiting for any late joiners to the webinar, I have a couple slides about our company to show you. We have just celebrated 21 plus years in business earlier this year, and in that time we've become a very large stocking distributor. We really do take to heart the slogan, buy from people, not just the internet, and we have a qualified staff here to help you. As you can see from this slide, as a national and international distributor, we cover the needs of a wide variety of customer types on the left-hand side. The right-hand side gives you some of the product and instrument types we carry. In total, more than 500,000 products. As you can see here from this slide, we've invested heavily in our website as a great resource and research tool. So you can see here there are the filtering capability of the specifications there on the left side of the page. We're showing just price range, but of course you can search by any number of varied criteria to describe the product to filter out the results that you don't want. We also utilize an internal portal that we have for better customer service, and we're constantly enhancing our website and internal systems to provide a better overall experience to our customers. And now, without further ado, it's time to turn over the presentation to John with FLIR. If you have any questions, please ask them through the chat feature, and John will be answering them at the end of the presentation and the intermission as well, which separates the two parts of the webinar. So now, John, I'm turned it over to you, and thank you for joining us.
Great, John, thanks so much for the introductions. Thanks all for attending today's webinar. Hopefully some insights we can provide for you to get some more information on our acoustic imaging cameras, as well as some of the changes for compliance related things in the area of NFPA 70B. So go ahead and get started. So goals for today, we got two main themes here. The first being ultrasonic imaging, capturing cost savings through sound. So we're going to get into a little bit of the science behind it, where to find those leaks in compressed air systems, some different application examples, as well as talk a little bit about our return on investment, realizing savings through finding these leaks. Then we'll transition over to some more compliance-related things, understanding what's new about NFPA 70B, not so new now. We're in December. Standard came out in January, and how this is affecting organizations like your own, what really the value and benefits of it, as well as how we can help and answer any questions that you may have. So without further ado, we'll go ahead and get started. If you have any questions, please do put them in the chat, and John will indicate to me if we have some things to follow up on. Okay, so why sound? So assets in the context of what we're talking about here with leak detection, they're going to emit certain types of sounds before they have breakdowns. This is typical in our partial discharge in utilities, but also in other environments with bearings and things of that nature. They're often very noisy environments. You can't really hear them, but what we do with our ultrasonic imaging technology is be able to turn that sound into value for you. So we're going to be able to identify sounds that are emitting from equipment in a way that are ultimately going to indicate a problem or an issue, whether it's a leak or a bearing problem or a partial discharge problem with an insulator or a connector in utility space. But this is really why sound is a valuable tool for your preventative maintenance efforts, and really focusing in, preventing those consequences of failure. So, systems going down, not being able to produce in a manufacturing capacity, not being able to supply air for different pneumatic controls you may have. It's kind of an important area where we've developed this tool around being able to identify those things early in the process. So the science behind it, really, how are we able to detect that sound? Really what this comes is the noise is created from turbulence. So these gas molecules are hitting each other because of that turbulence, and it creates an ultrasonic noise. It's a sound that you and we can't hear typically in those noisy environments, and it's going to produce that vortex ultimately that's going to ultimately give you that visualization of those leaks and of those sounds. And that's really kind of the basics behind that. You could certainly go into more detail, but more important to talk about how it adds some value to you and what you're doing there. So why are we using ultrasonic imaging for leak detection? Really, the directional nature of ultrasound, it really with our tool allows you to triangulate the source of that noise and display it on the screen. As you can see here on the camera on the right-hand side, we see a small little corona, and that's an indication of where that leak is coming from. And those sounds are directional, so we're able to pick that up through our microphones on the front face of that camera. And we'll get into some of the specifics on the camera itself shortly. And really, it's about being able to be more efficient in your inspection process. So it's usually about 10 times faster than point and scanning methods, maybe with traditional ultrasonic testers that you may or may not use in your organization today. The tool is very easy to use. It doesn't require a lot of training. And really where the value and the technology comes into place is the analytics side. So being able to separate those noises from that leak, from that background noise, which allows us to work in those typical industrial environments very effectively. And it's really quick, easy way to scan a lot of complex machinery very quickly. So you can walk your plant floor, you can walk your manufacturing space, you can walk in your mechanical rooms, anywhere where compressed air or gases are being used, and very quickly be able to pan the camera around and find those leaks quickly, and ultimately get some more information about what's going on in your facility. So what kind of leaks can we detect? In this particular case, focusing in on the gaseous leaks for today, but compressed air systems, steam systems, CO2 is a big one as well, a lot of manufacturing, as well as vacuum leaks. So these are all areas where we have the ability to effectively identify the source of those leaks, as well as perform quantification. So it's really just important to remember that the leak may not produce enough noise to be distinguishable from background noise. So, example, very small leaks like methane that are required to be detected in like different oil and gas industries on the upstream side, typically, they may not be detectable with this method. And then vacuum leaks produce that turbulence as well on the inside of that component, which means less noise is being transferred out. So depending upon the size of those vacuum leaks, it may be a little more difficult to find them, but it's not necessarily always going to be the case. And usually we're finding those leaks. It's just a matter of distance to target. Many times we have to get a little closer if you suspect that something there. But for today, we're going to really focus in on those compressed air leaks. And we know that these are detectable in almost all use cases that we're going to talk through. All right, so compressed air system leaks, this is really important. You see the money flying out of the piping there. It's really important. And why do we concentrate on these? This is area extremely high return on investment from you as an end user customer, where you are buying these tools, this technology to do many different things, but ultimately it's an energy savings method as air leaks cost money, and we'll kind of get into that in here. So typically, and this is based on the Department of Energy statistics that we've used here for all of these particular points that we're making, anything you see that's related to percentages, this is all backed by Department of Energy and their research. Compressed air systems are typically losing about 25 to 30% of their air to leaks. So your compressors are running more frequently. Really, what does that come down to? It means that there are higher energy costs to operate these units. It may be that your compressors are running more than you need to, which will introduce less return on asset for you. So you may need to replace those compressors more often, or in some cases buy additional compressors to increase capacity. And then obviously the extra maintenance cost for extra equipment and extra labor time to maintain those things. And really those costs are identified here, where the demands of the equipment are actually, if we look at the breakout, only 50% is really tied to actual production activities. Artificial demand, leaks, and inappropriate uses make up the other half, but that leak percentage is rather large. And those are things that we typically can focus in on with these acoustic imaging devices. We'll identify the source of those leaks as well as quantify them to determine how much it's costing you every year for those leaks in particular. And, it's really important to note tier 2, and I'm not sure how many manufacturing folks in here that we have on the call here, but 70% of all manufacturing facilities in the United States are utilizing some form of a compressed air system. So in many cases, they are very much in play where you are using it in your production as well as just in general operations of those buildings and facilities that you all may be operating out of. And then where to find them, right? It's important to know because there's a little diagram of mechanical space, all the different places that leaks can happen, whether it's the actual piping itself, connections, valves, flanges, the tools that are being used pneumatically, the actual distribution system. So various different places where those leaks are going to be found within the facility. So as you're doing your scanning quickly with a visual acoustic imaging camera, you can hit all of these places very, very quickly and identify locations of leaks as they are happening. These systems, the truth of it is they leak a lot because of they're complex. There's a lot of connections, and ultimately this is an issue where unless you are physically very, very close to a leaking distribution line, you may not hear the sound or the hiss, if you will, unless everything is very, very quiet, or if you're using other prescriptive methods around the old soap and water around flanges and soapy water around flanges or connectors. It's time wasting activity. It takes a long time to do it versus using the acoustic imaging technology. The air leaks cost money, of course they do, right? This source of this data is plant services information. It was an article written by Paul Studebaker called "Stop the Bleeding" from a few years back, and this is a low estimate. So the actual cost of this is based on a compressor running 8,500 hours, 8 cents per kilowatt hour for the cost. You can see based on both the pressure, so between 80 and 100 psi, and also the size of the hole or the opening, you can see the costs are rather significant when it comes to the impact of compressed air. So what does it really mean? This is from Plant Services Magazine, but this particular example, this is based on running 24/7 at 8 cents. We can expect those improperly maintained compressed air systems to cost the company tens of thousands of dollars a year, right? In this particular case. And, like I said before, the Department of Energy has some cost calculators. This is determining the overall cost of the compressed air, the energy cost in the facility from losses. And as the total horsepower obviously goes up, the estimated annual savings will arise. I don't know about you, but as far as using calculators, there's a lot going on here. One of the things that, we're pretty proud of here at FLIR is we try to really simplify that user experience. So we create a much easier calculator to use where you can basically, all the inputs here are what are in those equations, but you can establish an ROI calculator for yourself and for your facilities. The little QR code on the screen there, that'll take you directly to this particular calculator, but is available on our website. But it really will help you quickly ascertain what is the impact that compressed air loss is having in my facility based on my compressor horsepower, the time that it's running, the efficiency as it's fully loaded, when it's unloaded, how long or how often is it running per year, what's my kW rate for electricity, and estimated lost leaks, as we are using the Department of Energy's standard numbers here, even at 25%, and this is a pretty low estimate. This is costing annual electric savings of $68,000. We're purchasing this Si124 leak detection unit, and you're going to be able to identify and repair those leaks pretty quickly. If you don't have your QR handy on your phone to look that up, we also have the link there on the bottom where you can go and access this more directly. So So let's talk a little bit about applications, right? So this is an event with a lot of different industries here. I'll try to hit some of the high points within each of the industries and where these things make sense and where there may be application that could be directly related to some challenges you may be having. But in the food and beverage industry, there's a lot of issues around where leaks can create contamination of products. It's a reduction in capacity of the units that are producing these bottles in this particular case. Understanding that these leaks are going to have impacts beyond just energy, right? They are going to affect the operational side of the business as well, and then reducing that risk of contamination as the air is blowing things around the facility and getting into your products. That could be a problem. And then, with that being said, this is really tied to strict regulations around, production and manufacturing in this food and beverage industry specifically. So being able to identify those leaks, even the small ones, that's really important to be able to do that. We've seen a lot of success in the food and beverage industry with implementation of our acoustic cameras. On the automotive side, understanding that compressed air is used throughout the production process, within the different components in the assembly plants as well as in the sub-manufacturing spaces, is obviously energy waste being an issue, and then ultimately with operational and potentially safety hazards. Things are not a pneumatically controlled arm on an assembly line is not operating correctly or fails. It could have an impact on worker safety as well. And really the value here with the acoustic imaging camera, typically these environments are very noisy and we're still able to pinpoint those leaks and those challenges that are there in that space. On the pharmaceutical side, a lot of different types of gases that you're going to start to run into, a little bit more so than some of the others. And food and beverage, you're definitely going to run into CO2. It's very common, some of the plastics manufacturing as well, but in the pharmaceutical space, we're using compressed air, steam, gas. We also have a lot of vacuum leak issues. If these things are not detected, it could cause additional cost, could have problems with the actual production of drug, and any unplanned stoppages, obviously going to result in loss of revenue, overall equipment effectiveness and throughput of those productions are critical to being able to get that product out the door, and failures in those systems can have a major impact beyond just energy. And then, being able to detect air and gas leaks early, and once again, safety, being able to identify issues where machinery is operating as intended, so that there are no problems with the workers that are there using them. And then really what it comes down to is just ease of use in this particular use case. Obviously the costs and energy savings are there, but this particular company was really important in their decision-making process to leverage this technology. It's very easy to use, right? And the maintenance teams out there using this almost on a daily basis, being able to do troubleshooting as well as just a routine inspection program around finding those leaks. And ultimately there's some significant return when it comes to implementing it within this industry. Over on the textile side, this particular end user was a major textile manufacturing facility with hundreds of sewing machines operated pneumatically. They're almost running 24/7. Really just the efficiency of those machines, the stitching patterns and the speeds and how synchronized all those activities are, being able to find inefficient systems was very important. Obviously a very noisy environment, and the inspections can be done in a safe and efficient way while the machinery is running, so there's no downtime required to do any sort of testing or validation. And then also early stage detection of reduction in greenhouse gas emissions was another area where they saw some benefit, and just the safety concerns by eliminating noise pollution and harmful contaminants as a result of being able to perform these inspections more efficiently and eliminating problems where they were. Another key area is on the refrigeration side. So obviously a lot of refrigeration systems, food and bev, pharmaceutical facilities, they're all out there. Any industrial processes that require that heavy cooling or refrigeration, be able to identify refrigerant leaks as well. The camera can scan large facilities, detect ammonia leaks, depending on the pressurization of those leaks early, and minimize those environmental impacts as a result of being able to have a proper inspection and scanning program with this tool. Within pulp and paper, compressed air is a major component in that operation. A lot of pneumatically driven machinery, and the compressed air is, the annual leak loss is around 20 to 30% in most pulp and paper mills. And then with our cameras, like I said, and we keep focusing in on safety, but safety and ease of operation. It's very simple for these folks to be able to go out and scan large spaces, large distribution systems quickly. Any particular point in that maintenance cycle, pinpoint the problems, prioritize repairs, and you don't even need to shut down, in this case, to perform these inspections to get this done. And then really, taking into effect the industry averages and the things that are happening in that space, a lot of accidents, maintenance-related incidents could be avoided. About 90% of them are estimated with early-stage leak detection, before that becomes a major problem, where machinery then causes a more catastrophic failure because of an air supply issue. Being able to get ahead of that is really the message that we're trying to deliver here. On the mining side, not sure how many mining folks we got on the call today, but those are harsh environments. It's very simple to operate these cameras in those environments. A lot of pneumatics are used in the mining space, so be able to identify those leaks quickly, make those repairs, keep those mining operations up and running. And obviously, once again, talking about the noise in those environments, but being able to do that built-in calculation of those leaks and understanding what's happening is another benefit for that space. We glossed over it a little bit earlier on the food and beverage side of things. With CO2 emissions side, CO2 is very expensive, and be able to quantify and identify these leaks. There's one customer I worked with recently. We went in to perform a demonstration of the camera, and within 25 minutes found $11,000 of CO2 leaks in their facility. This was a very, very large facility, and we probably walked in a 100 square foot area of a multiple thousand square foot manufacturing space, and we found, like I said, $11,000 worth of leaks, and really being able to eliminate those leaks from a cost savings perspective, as well as sustainability goals that organizations have, is kind of a critical note here. So that's kind of the science and the application side behind the acoustic imaging. We're going to talk a little bit very specifically about the camera itself. The Si124 LD Plus in particular is our latest model that has all the advanced features that we're going to kind of get into. But really just wanted to point out, the different use cases apply along these different industries. We have a lot of folks that are realizing return on investment within days, let alone years, on technology such as this. And our role this last year has really been about educating that user base so that you all understand, what's the power of this tool and how can it help my organization, both from my energy saving goals, as well as safety and operational goals for the organization. So what are some of the benefits of the solution? So it is AI driven. We have smart functionality built within the camera to really provide a very nice user experience for the folks that are out there performing these inspections. Simple things like being able to perform auto distancing or auto filtering, to clear out any noise that's not germane to where we're actually shooting directionally, to understand where that leak is and how big it is, and really being able to ultimately save money and energy efficiency, improve that energy efficiency. The real power of the tool is we're able to find leaks as small as 0.004 liters per minute, very small leaks. And it's been tested and bench tested against other tools that are out there that perform similarly, and we're able to identify more accurately and faster than other methods that are out there today. There may be additional data that you need, so for maintenance or repair plans, not just that there is a leak, but able to quantify how much that leak is. So where it is, be able to quickly report on that information. We have some reporting tools as well with our Si124 viewer application, as well as some other Thermal Studio integration tools we have. But really just be able to prioritize those repair efforts, as well as ISO 55001, which is asset management standard that's out there for maintaining facilities in at a certain certain level for reporting needs. And really, this is where we find that customers like the tool even more. Obviously, it's nice to be able to identify where those leaks are costing money, but to be able to prioritize those leaks based on leak size and impact of the organization, and be able to get out and quickly perform those repairs. And then lastly, within this, the speeding up the process, to be able to perform these audits one faster, right? It doesn't require a lot of training. You can be out and using the tool pretty quickly. Most of the demonstrations we give out there are typically, not something that we like to show and tell, but we like to give and go, right? So here, take the tool, go out and do it yourself. It's very quick and very simple for them to go and do that. Unlike thermography, which requires a little more nuance to understanding, how to configure the camera to support what am I looking at, what are my ranges and things like that. This is a very simple tool to use, and like you said, can be used at any stage of your maintenance cycle. And really benchmarking this tool. This is the best performing acoustic camera on the market as of this year, with more to come. It's one-handed operation. That's something that a lot of our end users really speak to, in terms of the ease of use. Being able to get those quantification and leak rates on the camera as well as in software. So if you need to do more advanced reporting, you have that capability. But if you just need to know where they are and what's costing you, you can do that right on the camera screen. And it's also compatible on the software side. We have web-based software that is, allows you to quickly upload your images to the cloud if you are using cloud in your organization or allow cloud connectivity. So as you're capturing those images, you can automatically transfer them to the cloud. Or if you're not able to leverage cloud in some industries, it's a little more difficult, be able to pull those images off of the USB device or USB stick and import them right back into that software. As well as our compatibility with FLIR Thermal Studio. So be able to bring together your thermal reporting and your acoustic reporting into one platform really provides benefit to those end users. So some of the more specifics, talking some of the technical specifics around the tool, the auto distance function, this is kind of important where we need to know how far away so that we can effectively quantify that leak. To be able to get, the most accurate leak size estimates is really being able to auto distance how far away we are. And then it works up to 16 feet away for auto distance. You can manually set it further. And it will allow you to detect leaks from even further away. And really just the auto distance piece just makes it a lot easier for casual end users who may not have the full training to understand how to set your distances. And as you can see on the right-hand side of the screen there, it's a very simple plus and minus. If you needed to manually set them, you can do so. Very, very simple interface. And then the auto filtering side, be able to automatically determine the best filters. We have different filtering methods that can be applied so that we can isolate those sounds more effectively. You can also manually filter them in more advanced settings, but really want to hone in on where that leak noise is, get rid of the high and the low frequency background noise so we can isolate that more effectively. And then moving on to the on-camera analytics. What we're doing here is just recognizing that the sound leaks emit, be able to detect and pinpoint one or more on screen. So that's another benefit of the tool. We have a single mode or a multi-point mode. The single mode will find the biggest leak on the screen as you're doing your scans. Multi-mode will find multiple leaks at the same time on the screen. That auto distance feature, being able to, like I said, detect those distances. The filterings we've already talked about, and then automatically displaying the leak size and cost estimate in a very understandable format. It's as simple as you define your electrical kilowatt rate per hour on camera, and you can modify that and change it as needed. But then, work to automatically understand what those costs are in real time as you're actually doing the scan. And also presenting that sound level set also indicates the leak size. So as you get into more of the reporting side, you can actually look at the plot of that sound and be a little more specific in understanding the impact that's happening on your organization. So that's the Si124, kind of bringing some of the newer technology out to the user base and providing some insights on the power of that tool. And just before we move on to the next phase of our presentation here, just wanted to stop really quick and John, see if we had any questions before we moved on to NFPA.
No, not at this time. No questions. But if they do come up, I'll definitely let you know.
All right, that's great. I think it's certainly one of those things. I did have one question here. The Si124 work to find air leaks in loud environments. Yes, and that's really where the microphone array has 124 microphones, so that's the Si124 name. The multiple MEMS microphone array will allow you to triangulate and pinpoint those specific sound frequencies, the noise that is being emitted by that leak, and do so in some louder environments, because the sounds that are being produced in those loud environments are happening at different ranges, where the leaks are typically in a smaller frequency range that we can pinpoint down. And then I think, John, was there one other question?
Yes, I do see a question now. How far away can you be and still see an air leak? Is the question.
Yeah, it's always a great question. It depends. That's always the safe answer, right? It depends how far away it is and how
Sure.
it really comes down to the size of the leak and the distance. We can detect leaks from, up to, I think, 25, 30 meters away effectively, down to a smaller leak size. But I've done it where it's been 120 feet away because the leak was so large, we were able to isolate it pretty efficiently. So it really has to do with the size of the leak that you're trying to target. So 16 to 20 feet is kind of a max solid recommendation, where you're going to find, about 90% of those leaks that are detectable down to 0.004 liters per minute from a leak rate, which is a very small leak rate, and that's at 0 atmosphere. But ultimately, distance is really going to be relative to size of that leak. So hopefully that answers that question. All right. So moving on. So we talked a little about technology. Let's move into compliance. Right. So NFPA 70B. We're going to talk a little bit about what's new with the updates to the compliance and how it's affecting organizations. Maybe yours specifically, but really anywhere where we have electrical equipment that is, and the best way to quantify this, if you have some form of a transformer in your facility, basically you are in a position where 70B starts coming into place. So 70B is not for homeowners. It's not for smaller buildings where there is not a transformer stepping down power. It's really more in the commercial, industrial, institutional type spaces where you have larger electrical equipment that is through a larger distribution setup in the organization. So I do get that question from time to time. Figured I'd start off by answering it before we get into it. Okay, so what's new? And really kind of what I want to focus in here. What is the purpose of 70B? And taking it directly from the guidebook. The purpose of the standard is to provide for the practical safeguarding of persons, property, and processes from the risks associated with failure, breakdown, or malfunction, and a means to establish a condition of maintenance of electrical equipment and systems for safety and reliability. So while that is a mouthful, one important point to call out here is 70E, NFPA 70E typically deals with personal safety, things like proper PPE, distance, arc flash ratings, things of that nature. 70B is really focused in on the procedural aspects, as well as the levels of training and type of documentation that you need to have around your equipment. So the key takeaway, really, if you can get anything out of this, is that the guidance provided affects process, procedures, and documentation requirements, but most importantly, thermography, the language of the document has changed to where it is moving from recommended to required. And that's kind of an important distinction there, where in the past versions, thermography was recommended at certain maintenance intervals, or inspection intervals. Now it is now required, and the documentation explicitly calls out the when, and we're going to get into some of those specifics here soon. So what I did is we have three major components here: procedures, people, and documentation. We're going to kind of break those down a little bit more. I'm going to give you some reference pages here on the next couple of slides that actually will call out very specifically within the guidance. So if you needed to reference this for yourself, you have it. If you want a good long read, you absolutely can sit down and read this, but it saves you some of the trouble and try to make it and call it out specifically for you here. All right, so we mentioned thermal imaging language changing from recommended to required in section 7.4.1. This is where it is first mentioned and referenced, and there are two components here, and I'm not going to read all the stuff on the right-hand side because you didn't come here to leave me. Didn't come here to have me read slides to you. I'm just going to talk to this a little bit. So thermography used when verifying temperature differences, right? So we're doing this, when we're trying to determine the difference in temperature. And there are two important components here that I want to call out. So similar electrical components under similar loading, as well as comparisons between electrical and the component itself and ambient air temperatures. I get asked all the time, well, which one do I use? Well, the recommendation is if you're using it to verify temperatures of the following. So if you're doing your inspections and it is typically against ambient, that's fine. You just need to be able to document that. If you're dealing with similar electrical components under similar loading, what's really important to call out here is that the similar component needs to be under at least 40% load to be considered a viable comparison component. And your test target needs to also be under at least 40% load. So you can't have things that are too far off. If they're more than 10% off between the two, it's really not a good test. So if one is under 100% load, and others under 80% load, that's really not a good similar electrical component comparison. The important component here as well is that these particular activities at a minimum for any electrical equipment that is documented within NFPA, and it's all in there, it's all spelled out very specifically. The minimum thermography is to be done every 12 months, and that's typically based on condition. And there's also condition coding within the guidance, but no less than every 12 months for your inspections of your electrical equipment. The other two components on the procedural side is that there's a need for condition-based assessments, right? So as much as we're talking about thermography changes to NFPA 70B, the physical condition needs to be documented and included in the electrical maintenance plan for current equipment condition, and they call out some very specific sections there as well, based on what you need to do to qualify the conditions of those assets. And that's really important, where you need to have a solid electrical maintenance plan and understanding what do I have, what condition is it in, so when I go out and perform my inspection activities, I'm doing the correct activities given the condition of those assets, as well as ensuring that all of my assets are being inspected in accordance with those sections that are there. And then also detailed test procedures. So for all the equipment requiring maintenance, they do a great job here. I'm going to read a little bit, but where manufacturers' recommendations are not provided, there's an entire interval table that is provided by NFPA, as well as the specific tasks that need to happen from a maintenance and inspection perspective, the frequencies that those need to happen. So if you don't have manufacturer information or those recommendations are not in place, NFPA does have some really good guidance there to walk you through the specifics of what it is that needs to be done to maintain and perform all those test procedures throughout. Okay, moving on to personnel. So some changes on the personnel side of things. First and foremost is there's a requirement now for electrical maintenance program coordinator. And this person's job is rather involved. It really is about identifying all those systems that need to be documented and evaluated, as well as defining the scope and frequency of maintenance based on either manufacturer recommendation or the NFPA guidance that's provided. This particular role needs to be clearly identified throughout, and they have some responsibilities in the documentation and review and condition assessments that are going to need to be adhered to for compliance purposes. Two real important ones to call out here too. So personnel should be qualified to perform the test procedure on the specific equipment to be tested. So this is not just thermally trained operators of cameras. This falls into any specific maintenance tasks, testing methods, equipment, PPE, as well as hazards, and precautions around electrical equipment that's being serviced. This is really important to note. So it's not just thermography, but when it comes to qualified, if you need to take temperature differences and capture those through thermography, you need to be qualified to do so. And that typically means that you've gone through at least a level 1 ITC or infrared training certification process so that you are basically validating the fact that you are properly trained in the use of the tool, i.e. the camera, to perform those tests and testing methods. And that really comes down to that second point, that the personnel should be qualified to operate the test equipment itself. And that just comes, like I said, just in the camera side of things. We're able to use those cameras effectively. Excuse me there, just a little cough break. All right. Moving on to impact for documentation. Everyone loves some good documentation. I don't know, my background in maintenance and operations, a lot of documentation for maintaining that equipment, preventive maintenance procedures, requirements for regulatory bodies, all the things that need to be maintained. But there are some changes on the documentation side. Can I spell them out here? So delta T, or temperature difference, is required for all thermal testing. And this gets back into that 7.4.1 section, but the comparisons between electrical components and ambient air temperatures, you have to pick one and stick with it, right? You can justify the change between either similarly loaded. Most organizations are gonna leverage the comparison of ambient. It's just a little easier to do. You have the ability to set on our cameras the ambient air temperature right on the camera, so the calculations can be performed pretty quickly in the reporting side. But ultimately, it does require all thermal imaging be documented and include those temperature differences. Another question I get here all the time as well is, in the past, we've only documented issues, right? We've only documented problems with thermography. We're going out, we're doing our scanning like NFPA says we should. We're being good stewards of our assets, but from a reporting perspective, we're not really documenting things that are fine, that are okay. Well, that's no longer really the case here. You really do need to document all of those assets over time so that you can make sure that you're trending and tracking that information in an appropriate way. Understanding full well that the time of day that you take those images, the load that the asset is under, are all going to play into any sort of comparative analysis. But basically, you need to prove out that you've gone through all of your electrical equipment and done the documentation properly. And that gets us into the next section here, the maintaining of test records, including as found and as left results. And these are situations where some organizations will hire out a company to come in and do their thermal inspections, and then provide the reports back to you, and you go out and you make your repairs. You need to now document the as found condition. So if there was a problem, as well as left where applicable. And what that means is as repairs are done, documenting that the repair was completed, and here's the new thermal image maintained, new thermal analysis done to show that the repair was done. So it's important that those test records contain that information. That is line number 8 of, I believe, 10 or 12 in section 8.6.2. There's a variety of other things that test records need to contain, but I wanted to call this one out specifically as it pertains to thermal. And then the last one within the documentation side is test equipment calibration should be traceable to recognized national standards. We hear the term in the space all the time called NIST, so the National Institutes of Standards and Technology. That is a recognized national standard, and the equipment itself that provides any sort of measurements. So this is not just thermal cameras, it's any sort of test and measurement tool you're using in your electrical inspection program needs to be calibrated, and the calibration should be traceable. So it's important that you ensure that the tools that you're using to perform all these tests are calibrated and done so against the national standard that's out there. So those are the 3 main large areas and impacts to the organization. Just like I said, I wanted to call those out specifically. There's a lot to read in those documents, and we find that it's beneficial for folks to understand what are the things that are impacting the organization from maintaining compliance with that standard. We really want to kind of transition a little bit more into what are some of the benefits of adopting a program like this. There's no organization currently, and I say that in December. In January it'll probably change, that is enforcing NFPA 70B. OSHA absolutely enforces NFPA requirements around personnel and safe working environments. As we know, 70B just came out this year, so a lot of those other enforcement or regulatory agencies are going to be adopting this as part of their enforceable list of things that organizations can be held accountable for. But there's more to that, right? More than just compliance. It really speaks to the organization having a real commitment to safety of your assets and people in which they're operating those assets, and that state of good repair, right? So being able to focus on safety as a core to your electrical programs, where people clearly know what do we have, what are those hazards associated with it, what are the procedures, the proper procedures that need to be done for inspections and maintenance of those pieces of equipment, so that there's some really good emphasis placed on performing these activities in a safe way. And particularly with 70B, where you're performing these tests and these things under loaded conditions, you're going to have cabinets open, or even better, you're using IR windows in these cabinets to be able to do your scanning. But safety is really going to be a core to developing a strong program. And that programmatic approach, is really what it comes down to. The more you're invested in maintaining that equipment in a standard and uniform way, you're going to have a better outcome. You're going to see those asset reliability improvements happen in your organization because you're maintaining that equipment based on some recognized standards that are out there. Or, as I said before, the manufacturer recommendations, either one, are really going to be part of that electrical maintenance program. You're going to be more effective over time. And the last one, maintaining compliance. So I kind of hit on this at the beginning is, we're doing this because we need to. It's a good idea to, but as we move towards next year, there are going to be more regulatory agencies such as OSHA that are out there. They're going to be looking to this to ensure that you are complying with this standard. So if, heaven forbid, there were an incident, they're going to look at your maintenance records. They're going to understand, whether or not you were performing those thermal inspections or electrical inspections with the correct frequencies, and they're going to want to make sure that you are doing so based on the NFPA standards that are there. And the last part too is we're starting to see some insurance policy requirements be updated. A lot of them have some generic language in the underwriting documentation or the actual policy itself that says that you as a facility operator, owner, or manufacturer will maintain your equipment based on recognized national standards. I think you're going to start to see a little bit more specifics around this because NFPA in particular, they've done a great job at providing a very robust outline, as well as specific tasks, frequencies, intervals, and activities to support that equipment in the proper way, you're going to see insurance companies start pushing that even further. So just something to be aware of as you kind of enter in 2024. You just want to be educated and prepared to be able to support what you're doing there in a more meaningful way. So how can we help? And by way of T Equipment, how can we work together to help you? So really, we do have what you need to remain compliant with these new requirements. We are the leader in thermal cameras. We have the right tools to equip your team to perform these inspections. We have additional functionality just released around route-based inspections. So being able to load a list of all your electrical assets that need to be inspected right on the camera, to be able to go out and systematically perform those inspections, and then use report templates. We now provide a free report template for our Thermal Studio Pro customers for being able to, it's an NFPA compliance template, performs all the calculations for you, determines that your assets are being inspected properly, and like I said, that software itself to maintain those records, right, to be able to document that those things have happened. And then lastly, the training side, right? So understanding where if you are new to thermography or don't have staff that are properly trained through our infrared training center, we do offer those training courses to be able to support your efforts in your electrical program. We also have very specific ITC training around electrical systems that get into the proper way to perform those thermal inspections with various assets that are going to be inspected. And then lastly, just the cameras themselves. Just want to point out this delta T calculation. We're able to perform that on the camera itself, as well as in the software. So you can leverage those tools very effectively to streamline the process, with routing and get the type of reporting you need for compliance. So these are all, different ways that we can help in the NFPA 70B side of things. And ultimately, working with T Equipment here as a supplier for us and a trusted partner, absolutely can work collectively with you to determine how best to support your either implementation, expansion, or alignment with this type of program as you enter into the next year here.
Great. Well, thank you very much, John. That was a very interesting webinar. And we do have another question that came up. Any recommendations on how we could get certified to do the NFPA 70B inspections?
Yeah, so as far as the certification goes, the most important point to call out there is the requirements around training for the inspectors themselves, particularly on the thermal side. So getting staff engaged, the best thing to do would be to leverage our infrared training center website. Right now we offer a variety of different types of courses. They can also do on-site courses with larger teams, but the infrared training center at FLIR is absolutely a good right resource there, because that can validate that your team has the necessary training and certification to perform those types of inspections. So there are other trainings and testings, training around other tools in the maintenance process. Those are going to be unique to each of the different methods that are used. But when it comes to thermal, our infrared training center is absolutely positioned to ensure your staff are in compliance with those requirements.
Absolutely. Great. Thank you very much. Well, if we don't have any other questions, please keep in mind that you can always email them to us. Any questions that come up after the fact. Sometimes that happens to me, I know, where I thought I should have asked that one question, or maybe reviewing the information, you come up with a different question. So definitely forward them over to us. You can send it to me at sales@tequipment.net, and we'll get the answers to you right away, as well as any other additional information you might need, and quotes or assistance with these tools or with anything else. Also, please note that if you would like copies, PDF copies of the slides that were presented today, were very informative. We certainly can provide you with that as well. So if there aren't any other questions, I guess we'll end the presentation there. John, thank you very much for providing this information. It was very useful.
Thank you, John. Thank you all for attending today.